It's a decently tough set. What you need to focus is on the learning curve. How you start, how you figure out, and if faced with a similar question next, how can you, leapfrog and start from a better position. So there are N1s and M2s written. They take turns alternately, have to necessarily erase two numbers. If the numbers are identical, they write back a 2. If the numbers are different, they write back a 1. It takes time for us to figure this out. So the faster you can learn this, it's better. Same, write back a 2. Different, write back a 1. The game ends when there's only one number left, and if that number left is 1, first one player wins. If the number left is 2, the second player wins. So remember what we are going to do now. A confusion for those who find things a little difficult is we are going to talk about number of ones and number of twos. Okay, so the third thing that we have already learnt is start near the end. The number of ones and the number of twos. So start near the end, as in the end is when there's a single number written. So let's say there are two numbers written, and let's say both the numbers are ones. So remember, 20 is not. What is written is 1 and a 1. Now if 1 and a 1 is written, what can you do? You have to erase the identical numbers. And if you erase an identical number, you have to write a 2. So what this ends with is, this becomes a 0. There's no more ones. Remember, this is not a 2-0. There's no more ones, and there is a single 2. So don't write two 2's. There's a single 2. Therefore I said these are the number of 2's. And that is the end of the story, because a single number is left. Now the second player actually doesn't get a turn also, and he wins also. At the end it's 2, the second player wins. But this is too near the end to really meaningfully make much. Okay, so that this was 2-0. Or else what else could I have? I could have 0-2 also. 0-2 means there are two 2's. There's no ones. Then again the person is forced to erase identical numbers, and if he erases identical numbers, he'll write back a 2. So think how it's happening. 2 2's goes back and 1. So the number of ones still remains 0. This becomes 1, and that's the end of the story. This time again the first guy was forced to do, and the game ended. The second guy did not even play, but he won it because there's a 2 left. So with two numbers left, there's 2-0, 0-2, or there could be 1-1 also. I again repeat this, for the beginner this might lead to a confusion that on the board there's a 1 and a 1. No, there's a 1-1 and a 1-2. I'll not be highlighting this again because this will extend the video a lot, yeah, or else. Okay, so now the person is forced to erase both, and they're different numbers, and if they are different numbers, he has to write a 1, and that's the end of the story because there's a single number left. Oh great, so this time what is going to be left is the number of ones will be 1 and this will be 0. Finally the first guy won, but in all of this there was only one move that happened. The first guy did. Second guy did not even get a turn. Okay, so too small to get a pattern, right? Now, just for your learning curve purpose, students, not as an explanation or so on, I would think that one should go ahead with a little bigger numbers. Okay, towards the end, let's go the whole learning curve. So these are two numbers left, three numbers left. I'll start with 3-0. So what if it was 2-1? We'll come to it. But go in a method first, no? So if it is 3-0, the ones have to be erased. Both are 1, so I'll write back a 2. So this got reduced by 2, this got increased by 1. Oh, now I have a 1 and this I have already done. A 1-1 will end up with only 1-0. Okay, what if I had a 0 and a 3? All the numbers are 2, 2, 2. Two 2's are erased and a 2 is written back. So 3 left over 1, 1 written back became 2. This was 0. And have I already done a 0-2? Yes, that's the advantage of starting from the back. This is what has been taught in the concept videos. Reuse that. Okay, and now comes your objection. What if it was a 2-1? Now, if it was a 2-1, now there are two paths. Either I can erase both the ones, There are two ones, or I can erase a 1 and a 2 because there's a 2 also. So either branch out, say both the ones are erased. Okay, if both the ones are erased, I'll write back a 2. So this got over, this became this. Or, put an or, later will come back. Okay, or let's do this. 1, 1 and a 1, 2 is erased. A different number are erased. So the 1 is replaced. So 1 was erased and was written back. So this remained at 2 and this was erased, it became 0. Do you already know for 0, 2 it will end with a 0, 1? Do you know for 2, 0 it will end at a 0, 1? So, and you can do a 1, 2 ka case also, but hang on, pause. Now, these are two small numbers. I figured out how it's going on. Here the second wins, first win, second win, second wins. Yeah, whenever 2 is left, the second player wins. Yeah. Okay. But then I figured how it goes, but what? It doesn't tell me who is going to win or so on. So the problem with small numbers is you don't see the pattern easily. So this is a learning curve that I was talking about. So small numbers can help you, but the pattern is missing. So for patterns, you'll have to go to large number. And one of the way to go to large number is pick numbers from the question. So for example, for n and m being 5, the first player to move wins. Let's put that 5 and see. Number of ones, number of twos, and put 5 and 5. And let's follow one strategy and not switch over strategies here there so that we can be fast. So my strategy is 1, 1, keep erasing. If you keep erasing a 1, 1, you'll have to write back a 2. 1, 1 is erased. It became 2, this became 6. 1, 1 is erased, this became 1, this became 7. You wrote a 2. 1, 1 is erased. No, you can't erase 2 ones. You don't have 2 ones. Okay, now what do I do? Now I'll keep erasing 2 2s. Okay, just you can even do 1 and a 2, but that is what I said. Somewhere you have to take a call and go ahead. Now, so either replicate this many times. Okay, so where are we? I'll erase 2 2s. When I erase 2 2s, I'll have to write back a 2. Oh, so 7 became 5 and 5 became 6. 6 became 4 and 4 became 5. Oh, 5 became 3 and 3 became 4 and 4 became 2 and back to 3. Oh, it's reducing by 1. I can be so fast. Okay, and then now I can't erase 2 2s now. Don't be rushed saying, oh, I'll erase 2 2s, it becomes 1 0. You don't have 2 2s. Now, but this 1 1 you already know. 1 1 is going to end up with a 1 0. Okay, this was if I followed one strategy. What instead of 1 and 2s, I'll erase 1 and a 2. So let's see, 5 and a 5. Erase 1 and a 2. 1 and a 2 are different numbers, so you'll write back the 1, this will get done. Erase 1 and a 2, you'll write back the 1, this will get reduced. Erase 1 and a 2, you'll write back the 1 and this will become erased. Okay, so this is reducing now. Oh, 1 and a 2 is erased, you'll write back this will go off. Now you can't erase a 1 and a 2. Oh, now I'll have to erase 2 1s. 2 1s have gone, it will replace with a 2. So 3, 1. 2 1s have gone, or come back to 1 and a 2 you erase 1 and a 2, this will come back. This will become 0. Oh, now you're forced to erase 2 1s. So this will become 1 this. Oh, 1 1 has come back, 1 0. Oh, you already see the number at the end there's 1 written. If 1 is written, the first player wins. So it seems so. Now, this is a little more comfortable for pattern. And do you see that pattern? 5 3 1 1 1 1 5 5 5 5 5 3 3 1 1. Try to see what is it. This 5 6 7. Oh, increasing, decreasing. 7 6 5 4 3 2 1 0. 5 4 3 2 1 0. Increase, decrease, increase, decrease. Oh, it's switching, right? So a little more pattern is known than that. However, I'm still not perfect, and this is a last stage of learning curve where I've learned everything with numbers. Now, how do I graduate? I graduate by doing the same thing with variables so that I can get a snapshot of all that is happening. Okay, so I'll erase this side, its use is done, and we move to variables. Now, try to do it on your own, right? And this variables is what I would do a similar set later on with. So, if I say the number of ones and the number of twos, if I say it's A and B, quick, yeah. If I erase 2 ones, we have already done this. 2 ones I erase, I'll write a 2. So this becomes a minus 2 and this will become b plus 1 if 1 is erased. What if I erase 2 2's? Then I'll write back a 2. So a will remain and b will reduce by 1. 2 were removed, 1 was written back. This is if a 2 and a 2 is erased. What if 1 and a 2 is erased? You have done that but with variables. 1 and a 2 is erased, I'll write back the 1. So the a will remain a and the b will be b minus 1. Oh, I get the same thing even if 1 and a 2 is erased. So both ways, okay, and that's the end of the story. These are the only things that can happen. So what do you see in A? A will either reduce by 2 or remain the same. Check. Reduce by 2, reduce by 2, remain the same. Remain the same, remain the same. Reduce by 2, reduce same. Reduce by 2, same. Simple. Done. Understood. What happens to B? Either increase by 1 or decrease. Increase, increase, decrease, 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 decrease. Decrease, 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 increase, decrease, increase, decrease. Every step one. Great. Done. And last, you identify the key concept on which this is based. And that concept is that of even and odd, polarity. So I'm going to mention polarity as even and odd. And in A, we know that A will retain its polarity. So if it is going to be even, it will only remain even. If it's going to be odd, it will only remain odd. We have only done for the case of odds, but we can see that it remains odd. What about B? B is going to increase by 1 or decrease by 1. So B is going to switch its polarity. Switch polarity in every move. Right? This is important. Every move. So, do we also know that the total number of moves is A plus B minus 1? Check. If there are 10, next time it's 9, 8, 7, 6, 5, 4, 3, 2, 1. Every time it will reduce by 1, right? 9, 8, 7, 6, 5, 4, 3, 2, 1. 10, how many moves? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So there will be these many switches of polarity in B. Okay, and in the number of 2's, rather, let me say this way, the number of 2's. And if there are so many switches, will it end up with a 0 or a 1? I don't know. So remember, at the end, they will end up with either 0 or 1, nothing else. So the final nail in the coffin, which would make things very, very easy, is the number of 1's, the number of 2's. I write down all possibility with respect to the pulse, with respect to the concept what it is. It is based on whether they are odd or even. So I'll start with odd. Now, number of 1's will remain odd. So between 0 and 1, what will it be at the end? It can't be 0. It has to be 1. And if this is 1, the other has to be 0. But let me check this otherwise also. Let's see. A plus B, odd plus odd, is an even number. Even minus 1 is an odd number. So there are odd number of switches in polarity. Change back, change back, change back, change back. Odd number, change. So where does it end up with? It will end up with a changed state. So if it was odd, it will end up with an even. So between 0 and 1, which is even, 0. So did we check that up? Now all I have to do that is for the 4 cases, odd, 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 even, odd, even. Always stick to one style of working in your mind so that it's very clear. So let's go to odd. The same way, if this is an odd number, between 0 and 1 at the end, it cannot be 0. It cannot change to an even polarity. The number of ones will remain odd always. Okay, and if this is a 1, this end has to be 0. But let's confirm it by logic. Odd plus even is going to be an odd number. Odd minus 1 is going to be an even. Even number of switches. Even means change back, change back, change back. Even number is back. So it's back to even, which is this. So perfect. Let's this time start with B. What will this end with? This will end with odd plus even is an odd number. Odd minus 1 is an even number. Even number of switches means it will come back to odd. And if it will come back to odd, it will be 1. And if this is 1, this should be 0. Has it retained? Yes, between 0 and 1, had I started from here, it had to be 0. Okay, and what about if it is even and even? If it's even and even plus even is an even number. Even minus 1 is an odd number. Odd number of switches means change. Even will become odd, so it can't be 0, it will be 1. Okay, and if this is 1, this has to be 0 and it is retaining it. So this is what happens in the 4 scenarios. So in this scenario, first player wins. In this scenario, second player wins. What is differentiate? Here we have odd. Here we have even. Here first player winning. This could be odd or even. Any of them. First player losing. This could be odd or even. Okay, so this doesn't matter. It only matters is the number of ones. Is it odd or is it even? That's it. So let's quickly finish the questions. Which of the following is necessarily true? Both are odd. Anyways, I just have to check this. If this is odd, first guy has to win. The first player to move wins the game. Yes. If number is even, the number is even, then the first player should win. The first player to move, oh sorry, my mistake, nah? Sorry. If this is even, the first player has to lose, second has to win. The first player to win wins. No. N is odd. First player has to win. The first player loses the game. No. N is even. The second player wins. The second player loses. No. The second player wins. The questions, once you get that, it's pretty easy, students. Otherwise, these are very tough questions, right? If A starts the game, which of the following could be the value? Now, A is starting of N and M such that he can win. So, A starts and A wins. So, the first guy wins. If the first guy wins, the only condition I have is N has to be odd. So, N has to be odd? No. So, this is my answer. Done. Which of the following could be a possible value of N and M if the last player to take a turn is the player who starts the game? So this is again a little tough, students. Yeah. So the one who starts the game is the one to play last. So if this means is the one who has to play last, what is the meaning of this? Let's see. So first, second, let's talk. First, then second. First, second, and then first. So this means there are an odd number of turns. Odd number of turns. Oh, and number of turns is nothing but A plus B minus 1 is the number of turns. So this has to be odd. Okay, A plus B minus 1. So if this has to be odd, this also means A plus B has to be even. Okay. And the game is won by the second player. The second player wins. If the second player wins, this means that A or N in this case, I am using A and N interchangeably, A has to be even. And if A and B have, A plus B has to be even and A is even, it further means that B has to be If the second player wins, A has to be even, perfect, and then this goes down to odd, or what? If A plus B is even, okay, B also has to be even. Only then A plus B will be even. You don't need so much, you can use these also, but if you would have done this analysis, then I just need amongst A and B, I need both to be even. So both are even here. This is even, but this is odd, doesn't work. This is odd, doesn't work, right? So neither does this work, nor does this as a pair work. But this works, right? Let's confirm it once again if you want here. So this is 24 and 36. The total is 60. So if there are 60, there are going to be 59 moves. So is the first player to take a turn who starts is the last to play? The last player to take a turn is the first one. If there are 59 moves, first, then the second, first, second, first, second, 59th will be the first player. And is this even? Okay, so the first player is going to lose. The second player will win. Yeah, done. You can check the others, right? If at some point in the game the number of ones left is 11, so the number of ones left is 11 at some time. So I know that at start it has to be an odd number. Okay, the question is asking started which, the first one has to be an odd number without in thinking or reading further, the answer is done. But let's see if there's something learning oriented. The number of 2's. Okay, and the number of 2's left are 8. Now if the number of 2's will decrease by 1, right? So this total is 19. But I don't know the move number. Had he said at some point, had he said which move, after how many moves, then also I could have figured it out. So the question is done, students, right? But I'm just saying there could be a little more tougher question. It could have said that after 10 moves, this is the stage. If this was the stage in 10 moves, then at start the total would have been 29. Because every move, 1 gets reduced. Okay, so if 10 has reduced, 10 moves have happened, or right, if 10 moves have happened, it's reduced by 10. And if I knew this, I could even have figured this out, but those things are not over here, so I don't need to check anything further. This is all extra stuff, students. Yeah.